Alright, so we're moving on to Unit 7. We finished Unit 6 with the van der Waals equation and real gases, deviation from ideal gas. Um, we're starting Unit 7 with solutions, but the whole title of the unit, I'm going to just write it and erase it. It's solutions and acids slash bases. So these are the topics we're going to be going over. GWiz info for right now because it's technically on Canvas as well. But anyways, we're going to go over solutions for a while. We kind of already touched on them with Raoult's law. The only reason I wanted to go over it is because it dealt with vapor pressure, but we're going to review it again. You're going to be tested on Raoult's law and quizzed on it this unit. That's why I didn't include it on the test last unit, 'cause technically it's with solutions, but it deals with calculating pressure. So, and, volatile chemicals. So anyways, we're going to start with solutions, going over the definition. Wow, that is a horrid start. Let me rewrite that so it's a little more clear. Alright, so solutions are homogeneous mixtures. So homogeneous mixtures of two or more substances. And I'm going to go over, we've already gone over this part, but I'm going to do it again. This was in Unit 1, I think. So in a solution, you have two components. You have your solute, and you have your solvent. Wow. Alright, so your solute is the substance that gets dissolved. And then your solvent is substance that does this dissolving. Substance that does the dissolving. Okay. So, give you a second to copy that. Just pause the video and keep going. So, to make a line here. Wow, that was a fail. Anyways, so we have, I'm going to go over the types of solutes. Hang on 1 second. Okay, so the types of solvents that you're going to see is we have electrolytes, we have, and non-electrolytes. So okay, so an electrolyte is an ionic compound. Let me move this down because I like having space in between. Okay, so electrolytes are ionic compounds. And then metal, non-metal, that's definition we've been using since like Unit 3. Okay, non-electrolytes are covalent or molecular compounds. So within electrolytes, you have strong electrolytes and weak electrolytes. And then I'm going to do the weak electrolytes later. But a strong electrolyte is something like sodium chloride or potassium chloride. It is a soluble ionic compound. Sorry, my pen's acting up. So you have a soluble ionic compound and dissociates completely in water. Alright, so for your example, you have NaCl turns into Na plus 1 plus Cl negative 1. Okay, I'm going to have to move this down just a tad so I have room for the other one. And then for B, we have weak electrolytes. So a weak electrolyte is an insoluble ionic compound. So an example of that would be like silver chloride, or remember when we did precipitation reactions? The insoluble that you're precipitating would be a weak electrolyte. So it's got partial dissociation. And then, your example would be, let me do this in blue just so everything stays the same. So it would be like AgCl, except this one's got an equilibrium arrow, and you have Ag plus 1 plus Cl negative 1. Alright, so when you would mix sodium chloride with water, you're going to have only ions. Like, that's it. When you mix silver chloride with water, you're going to have mostly solid and few ions. So that's the key that you're going to be using. So pretty much that's why you have precipitation reactions, is they're just insoluble in water. You're going to have mostly a solid powder or crystals or something like that form. So with non-electrolytes, you have covalent or molecular compounds. They have no dissociation or ions. So an example would be CH3OH, and you have CH. This is really not that good of an example, but because it does kind of dissociate with acid as an acid with that, but we'll get to that later. So anyways, you have just a recap. you have, if you have a strong electrolyte, you have only ions. And then you have a few ions if you have a weak electrolyte. But more importantly, mostly a solid. And then non-electrolytes, you have no ions. So if you need to copy that, go ahead and pause the video right now, and we're going to keep going. So I'm going to go to a new page. Alright. The ability of a substance. So that's referring to, in this case, your solute. Wow, I cannot write today. Here, hang on a second. So the ability of a substance, your solute, to dissolve in another substance is called solubility. So I'm going to recolor that so you know that's the important word. So, and then when a substance doesn't dissolve, when a substance doesn't dissolve in another substance, such as water or, an alcohol or some sort of solvent, it is referred to as insoluble. So I'm going to color code that a different color so you know that's important. So let me move that down so we have some space. So, anyways. And then there's another term for solubility or soluble. It's called miscible. And then it's used mostly for liquids in other liquids, not water. Usually solubility is for water, but it doesn't matter. Just miscible, does it dissolve in this liquid? And you can use it for water too. I've seen it both ways. So, how solvents work. So let's do a little line here. How solvents work. It's simple. Likes dissolve likes. And then similar intermolecular forces. So, for example, which of the following substances is most soluble in water? So your choices are, we have A, B, and then C. So A is going to be this one. B is this. And then C is this one. So pause the video, think about it for a second, and then pick your answer, and I'm going to go over it. Alright, so if you look, water looks like this. I'm going to do it in blue. So this one right here should be an automatic no, because there's not even an OH in it. It's not like the other one. It's just carbon and hydrogen. These two should be your most viable choices. Now, the one that's most like water is B, because it's got the shorter carbon chain. It's only got 2 carbons. This is ethyl alcohol. This one is butyl alcohol. It's got 4 carbons. But because of the increased amount of carbons, it's actually less polar. It's not going to dissolve as good in water. It'll still dissolve, but ethyl alcohol is way better. So B would be your answer, simply by process of elimination. This isn't really too complicated. It's which one is the most similar to this. So bigger carbon chain. And carbon chain is just referring to chain of carbons in a row. So bigger carbon chain. Carbon chain, or I'm going to put this instead of carbon chain. Bigger carbon / hydrogen chain. Lowers solubility in water. So, another concept that you need to be aware of. So, solubility of solids in water depends on temperature. And then solubility of gases in water depends on pressure and temperature. So I'm going to give you a second to copy that. Just pause the video. All right, I'm going to keep going. So to express the solubility of a solid in water, we have to use a certain ratio. So you use this format. So for a solid, you would have grams of the solid divided by 100 grams of water. And just to recap, density of water is 1 gram over 1 milliliter. So you can use this as a conversion factor. So, say I gave you like 200 milliliters of water. Or, let's do this. You have 250 milliliters H2O. How many grams do you have? Well, that's easy. Just use the density. So you have volume times mass over volume. And now you have 250 grams H2O. You've already kind of been doing that, but just to kind of remind you. So, the solubility of substances usually has like a tabulated value that you can follow. I'm going to do for potassium nitrate. So KNO3 has a solubility of 43 grams KNO3 or 100 grams of water at 30 degrees Celsius. So say you can actually determine how saturated, unsaturated a substance is just by looking at tabulated values. And let me fix the microphone. Okay. So we have types of solution. And then this is just how it's represented as like an example. So types of solution based on concentration. And these are words you've heard before. So, and then type, and then amount or concentration is just amount of solute. Alright, so you have saturated, unsaturated, and supersaturated. So saturated is a solution that has solute and solvent in dynamic equilibrium So what that means is will not dissolve more solute. It's saturated. So unsaturated is exactly what it sounds like. Sorry about that, my dog was barking. Anyways, unsaturated means you have a solution that has less solute than a saturated solution. That's an ugly S. So if you add more, it's still going to dissolve up until it gets to saturated. So for example, since I already gave you these values, it's for KNO3. So we have saturated, which would be 43 grams KNO3 over 100 grams H2O. And then this is at 30 degrees. And then same thing over here. Over here we have 30 grams KNO3 over 100 grams H2O. So this would be your unsaturated solution. So when I was talking about there was one more state, supersaturated. How does that happen? So supersaturated is interesting in that it's a solution that has more solute than its saturation point. Man, I cannot write today. This is crazy. Okay, so how does that work? So I'm gonna copy this and go to the next page. So at 30 degrees, so we have 30 degrees Celsius, KNO3 has a saturation point of 43 grams over 100 grams of water. Well, let's say at 40 degrees, we have 45 grams KNO3 over 100 grams H2O. So what happens is if the temperature increases, you can increase the saturation point. So interestingly, with a supersaturated solution, you can have the temperature decrease back to 30 degrees Celsius and still have 45 grams dissolved. But as soon as you agitate the water or whatever it's dissolved in, it's going to come out of solution that little bit and go to the original saturation point. So you have some powder come out. But if you just leave it alone, it'll actually stay in. All right. So I'm going to give you some practice problems. Let's see how we're doing on time. Okay, so we'll end with the practice problems. So if the solubility of sodium chloride or table salt at 50 degrees Celsius is 38 grams NaCl over 100 grams H2O, which solution will be saturated? So there's more than one answer. And use common sense. If you have a question, you can ask me about this. So 35 grams over 100 grams. I'm going to make more room here. $76 grams over 100 grams. 15 grams. All right, so pause the video, circle which one or ones that you think is saturated. Okay, so we're going to go over this. Obviously, that one is saturated because it's bigger than this. This one is saturated. These two are both unsaturated. Just because it doesn't have to be at the saturation point. If you had 38 grams, you can actually figure out how much is not going to be in solution. So 76 minus 38 is 38. So you're going to have 38 grams of solid NaCl in the solution and 38 grams dissolved. So this one, you have 40 minus 38 is 2 grams NaCl. So you're going to have a little bit less, but you're still going to have some powder in the solution. That's kind of how this works, and this is at 50 degrees Celsius. You increase the temperature, you can dissolve more. Decrease it, you can dissolve less. And if you have any questions on this, please let me know. Sorry about my dog barking. I'm going to try and edit that out.